Hi students, in this video we'll be looking at number sequences with a common difference. Okay, so mainly we'll do two things. First, we'll learn how to break down each term in the sequence, and then finally we'll learn how to come up with an expression for the n term of the sequence. Alright, right. So why do we call it a number sequence with a common difference? Because as you can tell, okay, let's say for this first number sequence. The first term is 7, and then the second term is 11, the third term is 15, and then the fourth term is 19. So you can see that between each of these terms, right, they have a difference of 4. Okay, so mainly what you will do to get to the next term will be to just add 4 lah. Okay, so that's why we call it a number sequence with a common difference. Okay, so there's actually a name for such a sequence. So it is actually known as an arithmetic. Okay, arithmetic progression. Okay, or an arithmetic sequence. Okay, whereby you add a common difference to each term. All right, so how do we break down each of these numbers? So the first term is okay, we'll call this term 1. Okay, this is term 2, term 3, and then this is term 4, right? Okay, so how do we break down this first term? Okay, so the common difference is 4. Okay, so you will realize that you'll always be able to break it down in this way. So 7 can be written as 3 plus 4. Okay, so this common difference must always appear inside the each term, right? Okay, then for this 11, right, it will be 3 plus 8. Okay, so you are wondering how just now I just mentioned that the common difference need to appear inside the term, right? Okay, but now it's not there. Okay, but let's see what we can do with the 8. So I can write it as 2 times 4, and you can see the common difference is now inside the term itself already. Okay, we can do the same thing for 15. 15 we can write as 3 plus 12, so it will become 3 plus 3 times 4. You see the common difference is inside again. Okay, then we'll do likewise for this. 19 will be 3 plus 16, and then 16 we can write as 4 times 4. Okay, so over here, okay, let's write this first one as well. So the first term we can write as 3 plus 1 times 4, right? So what are the common things that you can observe from each term? Okay, there's a 3 in front. Okay, there's a 3 in front. Okay, and then the common difference is there. Okay, so what is the only thing that is changing between all these terms? Okay, let me change the color of my pen. Okay, so what is the common difference between all these terms? Okay, so you can see the number here is different, right? 1, 2, 3, and 4. So the difference is in the numbers. Okay, the number in front of the common difference. Okay, and for number pattern, what we want to do is we always want to relate this changing number, right, to the term number. So as you can see, when it's term number 1, this number here is 1. When it's term number 2, this number here is 2. When this is term number 3, the term here is 3. When this is term 4, the number here is 4. So there's a pattern over there. And the other things remain constant, right? So in other words, if the question asks you for the n term, okay, what is the expression for the n term? Then we can easily write out. Okay, the 3 is constant. Okay, this 4 behind is a constant. This is the common difference. So what changes is here, right? And you can see that the number in front of the common difference will follow the term number. Okay, so this will just be n. Okay, so if we were to write out in the usual way, so it will be 3 plus 4n. And this will be the expression for the n term already. Okay, so this is how you come up with the expression for the n term, right? Okay, so let's practice this with one more sequence first before I show you a very quick way to generate the n term for the expression for the n term, right? Okay, so let's do another example. Okay, so we have another sequence here. So what's the common difference? Okay, so we can see clearly that this is plus 7, plus 7, and then plus 7 again. Okay, so you keep on having plus 7, plus 7, plus 7. Okay, so remember what we do? We broke down the first term into something plus the common difference, right? So in this case, the common difference is 7. So what plus 7 will give us 3? Okay, so what plus 7 will give us 3? So you can see over here that this number is -4, right? So it's okay to have a negative number. Okay, it's okay to have a negative number. So we can write this as -4 plus 1 times 7. Right? Then how about this? So this is term 1. Okay, how about term number 2? Okay, will be -4 plus 14, right? Okay, so -4 plus 2 times 7. Okay, then this will be -4 plus 21, right? Okay, will be -4 plus 3 times 7. So this is term number 3. Okay, this is term number 4. Okay, so you can do it faster and faster already. So -4 plus 4 times 7. So once again, we can notice that okay, this term number is the same as the number here. This term number is the same as the number here. This term number is the same as the number here. This term number is the same as the number here. The -4 and the 7 remains the same. So if they want you to find an expression for the nth term, it's just going to be -4 plus n times 7. Okay, and if we were to rearrange it, it will be 7n minus 4. So this is how you come up with the n term, okay, the expression for the n term for and number sequences with a common difference. All right. Okay, so now I'm going to teach you a method to generate this very easily without having to break down the terms itself. Okay, so let's go back to the first one. So the sequence is 7, 11, 15, and 19, right? Okay, so the first thing they will go for is that you look at the common difference. So it's +4, +4, +4. Okay, so what we want is the n term, right? Okay, so n term, the expression for the n term. So the moment you see +4, +4, +4, you can write down 4n already. Okay, and what will be the number behind? So just now there was a number behind, right? Which is the 3, right? Okay, so how do we get the 3? So basically to get the 3, you just imagine that there's a term 0 behind. If I go behind to get a term 0, what will be this term? So what number +4 will give me the 7? It will be a 3, right? So this 3 is the term before the first one. So actually this one is term 0, the 0 term. So you can very quickly get this answer out, right? So we can do likewise for the second sequence. Okay, 3, 10, 17, and 24. Okay, so we know that it's +7, +7, +7. Okay, so the moment you see +7, +7, +7, you write down 7n. And then you go and search this term 1, you go and search what is term 0. So what is the term over here? So what +7 will give you 3? So we know is -4. Okay, so straight away we can write down the expression for n term is 7n minus 4. Right, so this is the common difference. Okay, so this is the common difference. Okay, this is the term 0 or the term before the first one. Right? Okay, so some of you are asking now about what if the sequence is decreasing? Okay, can we still apply this now? Okay, so the answer to that is no problem. Okay, if this the first time is 37, then we get to 34. Okay, now we are subtracting 3 instead, right? So 34 goes to 31, we'll subtract 3 instead. 31 goes to 28, we'll subtract 3 instead. Okay, so the moment you see now -3, -3, -3, you write -3n. Alright? Okay, then same thing, the number behind is going to be the term before the first one. So this is term 1, what will be term 0? So what -3 will give you 37? It's going to be 40. So it's going to be +40. Okay, so we can actually test this out. Okay, let's say this is term 3, right? This is term 2. Term 3 is 31, right? So when n is 3, we should get 31. Okay, so when n equals to 3, okay, term 3 will be minus 3 times 3 plus 40. So indeed, minus 9 plus 40, we get 31. Okay, so now you know a very quick way to get the expression for the n term. Okay. Okay, so now we'll end off by taking a look at one question from the O level. So this is the 2012 paper 1 question 7. Okay, so if you look in your TYS, there are several questions like this. Okay, usually in paper 1 that's very similar. Okay, so let's analyze this. Okay, so the first 4 terms of a sequence are 5, 9, 13, and 17. Write down the 8th term. Okay, so this one is not difficult. So the first term is 5 plus 4 to get 9, 13, then 17. So the pattern is you keep on adding 4. So the 5th one will be 21, 6, 25, 7, 29. Okay, and the answer that we want, okay, you will write in orange, will be 33. Okay, so the 8th term, okay, so term 8 will be 33, right? So this will be the answer. Okay, okay, so now let's practice what we just done. Find an expression in terms of n for the n term of the sequence. So this one is what? Plus 4 plus 4 plus 4, right? So plus 4 plus 4 then plus 4. Okay, so plus 4 plus 4 plus 4. So what you can write n term or Tn, okay, will be 4n already. Okay, then next one you search for the number in front of the first one. So if there's another number in front of first one, what plus 4 will give you 5, so the answer will be 1. So it's 4n plus 1. Okay, so this will be the answer. Okay, let's test it out for term number 8 and see whether we get 33 or not. Okay, so when n equals to 8, okay, term 8 will be 4 times 8 plus 1. So 4 times 8, 32, 32 plus 1, you get 33. So this verifies that our answer over here is the correct one, right? Okay, so one term in the sequence is 205. Find the value of n for this term. So now they're telling you that there's this one term in this particular sequence. So this sequence will continue, okay? Continue on. Okay, until it reaches big numbers like 205. So what is the value of n for this? So all we need to do is equate this 4n plus 1, okay, to 205. Okay, because 4n plus 1, when you sub in different values of n, okay, of course, n need to be a whole number. You will get different numbers in the sequence. Okay, so 4n plus 1 equals to 205. So 4n will be equals to 204. Okay, you divide by 4, you will get 51. Right? Okay, so I hope this video is useful for you. Okay, in terms of analyzing number patterns with a common difference, okay, also known as an arithmetic progression, right?